Hey everybody, so we're going to look at Saturn now. This is 8.3 or 8.4, now I can't remember, in your book. We're finishing up Chapter 8 this week, and remember that Chapter 8 is all about the outer planets, starting with, of course, Jupiter, and now we're looking at Saturn, and we'll be looking at the ice giants, Uranus and Neptune in the next part of the lecture. Okay, so Saturn really was kind of a mystery to people who first looked at it with the telescope. So, for instance, Galileo looked at it in 1616, and to him it looked like Saturn had ears, right? So these things that were sticking up to the side, and sometimes those ears were not visible because of the tilt of Saturn. We'll see something more about that. But when he looked up at some points in Saturn's orbit, it would see that the ears were not there anymore. So they were pretty much a mystery for a while until Christian Huygens observed with Saturn, which much larger telescope, and recognized that there were rings around Saturn. And that's, of course, everybody knows that Saturn has these beautiful ring systems. And you guys saw in an earlier lecture that those rings are actually made of many kind of icebergs orbiting Saturn, and that are continually getting broken apart and resurfaced so that they remain very bright to our eye when we look through a telescope. So I hope that some of you have gotten a chance at some point to look through a telescope, even a smallish telescope. You can see the rings. Not certainly in the great detail that you see from, say, the Hubble Space Telescope, but you can see the ears of Saturn. So it's really kind of an amazing thing to look at. Okay, so let's delve in a little. So Saturn is, of course, as you probably already know, the second largest planet in the solar system. And if you wanted to fill it with Earths, you could put about 760 or so Earths into Saturn's volume. And it has this beautiful ring system. Now, we also know that some of the other outer planets have ring systems. Even Jupiter has a small ring system. So this is not uncommon for these gas or ice giants. Again, Jupiter is a gas giant. And so it's really interesting, though, that it has this really spectacular, big, visible ring system. Just like Jupiter, it's mostly hydrogen and helium. But the really interesting thing, I think, about Saturn is that its density is very much lower than Jupiter's. It's lower than the density of water. And it's the only planet that has a density that low. And one of the reasons that it has a density that low is that it rotates very, very fast. Rotates once around in about 10 hours, so quite fast. And just if you think about something rotating that fast, you can imagine that in the equatorial region, you're going to get sort of a pulling away from the core, which would lower your density. Remember, density is the amount of mass you have per volume. So if you increase the volume and you keep the mass the same, you're going to get a lower density. Okay, so we think that there's a dense core in the middle, just the way we thought for Jupiter, right? There's also that metallic hydrogen, just like Jupiter, and we do get a magnetic field. Not as strong as Jupiter by any means, but do get a magnetic field from that metallic hydrogen. And there's also that sea of molecular hydrogen, H2 molecules. So very similar in a lot of ways to Jupiter. Okay, so this kind of rotation, this fast rotation, is really causing Jupiter to be kind of oblate. So what oblate means is, imagine you'd have a beach ball and you just put it on the table in front of you and you squish it down from the top, and you can know it'll be kind of this oblate, like almost oval-y shape, right? And that can happen due to fast rotation, and it actually happens to all planets, and even Earth is slightly oblate. But you can see here from this picture of Saturn with a circle. So this would be, if the planet was perfectly spherical, then it would be touching the circle everywhere. But it's not. It's kind of squished, like someone is pushing down on it from here. And this is simply due to how fast it's rotating. So quite oblate. It has a good strong magnetic field, but of course not as fast. I mean, not as big as Jupiter's. It's got a smaller magnetic field. Okay. So it, just like Jupiter, it emits a lot of energy, more energy than it receives from the sun. And that's, I hope that's surprising to you, because it certainly was to me when I first heard about it. You assume that, planets that are far from the sun are going to be cold, and why would they be emitting energy? But they are. And one of the reasons um, that Saturn is emitting energy is that there was actually helium rain happening underneath the clouds and in the area of the planet that is in its sort of hydrogen ocean. So what happens is the conditions are just right for helium to condense, just like water condenses out of our clouds and falls to the ground as drops of rain. You get drops of helium that are falling down, and when they fall down, they release that gravitational potential energy that we've learned about in the form of heat. And that's contributing to heating of Saturn, the fact that it emits more than 2.5 times what it receives from the sun. So, do you remember there's a song that I posted? It was Drops of Jupiter. I really should have been Drops of Saturn, right? Anyway, it's about helium rain on Saturn, which is, again, thought to be a big mechanism that's helping to heat Saturn up. Okay, again, so we said that, those ears would disappear here and there for Galileo when he looked at Saturn. And you can see that, sometimes the rings are a lot more visible because of the way we're looking at Saturn, given its tilt, right? Okay, so you can see different as it goes around. So if we think about from 1980 to 2003, it went around, so you can see it went around almost 3/4 of the way. And you can see that from our perspective, the tilt really, our perspective on the rings changes. So this is why those ears were disappearing here and there. As Saturn would go around the orbit. And you could barely see them when it's edge on. I mean, you can kind of see them, right? But imagine you're looking at this with a Galileo-sized telescope, which is not very powerful telescope at all. It would be much harder to see them here than it would be here. So this is why you get some changing views. And it's nice to go and look up what the view to Saturn is before you try to look through a telescope at it. And hopefully you will be, you can observe it in this phase. And you can see from here, you can easily go look up what the view of Saturn would be today. Okay. Saturn's atmosphere, again, we said it was mostly hydrogen and helium. But the really interesting thing I think about Saturn, if you notice pictures of Saturn, so if we go back to our pictures of Saturn, you can kind of see it's kind of a muted, right? It's got muted colors. It's not that whirling, beautiful, crazy colors of Jupiter. It's covered with basically a hazy, sort of like someone took, on Photoshop where you can use your like, it's like a dropper that kind of blends colors in. It kind of looks like someone did that to Saturn. And that's because it's so far away from the sun, the higher layer basically has this haze that has formed that masks all these lower layers. So those beautiful colors and stuff that we got on Jupiter, we're just not going to see because of the haze. And that's due to the fact that it's farther away and colder, farther away from the sun and colder on the upper atmosphere. So, of course, below that haze, though, we think that there are belts and zones just like there were on Jupiter. Lots of roiling and and convection because of the heating happening the way that Jupiter, maybe not as intense given that Saturn's a little smaller, but that they're similar cloud structure, just lower. Now, the really cool thing too about Saturn, because it rotates so fast, is that you get super crazy high winds. So winds up to 1,800 kilometers per hour. which is just kind of unheard of. So really kind of amazing. And those, again, that kind of wind action is driven by the very fast rotation of Saturn. Now, Saturn has something that I think, and it's not unusual in the solar system. So it has these storms. Kind of think of that big red spot on Jupiter. That's a big sort of hurricane-like storm, right? But it has these storms that are at the pole, so at the North and the South Pole, and these big giant storms. But the coolest thing about the one at the North Pole is that it has this hexagonal shape. And this picture does not do it justice here, and I'm going to point you to a video in a second where you can watch that tells you all about this hexagonal storm. Big mystery for a long time. How could you get something that was really hexagonal? And you're going to see that in the video. So let's take a look at that video. Now, I'm not playing it in this video. So in other words, you see probably when you loaded up this question, there's this video. Then there's this next video that you're going to watch. And then afterwards, there's going to be another video where I sort of sum up and give you the beginning to your first question of this lecture. So I'm going to stop here, play the next video in the list.